Welcome to question 1 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. So for question 1a we're asked to differentiate x cubed times e to the power of 2x with respect to x. And because these are two simpler terms multiplied together, we're going to use the product rule to differentiate. So to apply the product rule, we're going to let u equal x cubed and v is going to equal e to the power of 2x. And now we're going to calculate du dx. So du dx, the derivative of that is 3x squared, and v dx, the derivative of v, is going to be 2e to the power of 2x. So from the formula sheet we know the derivative d dx of u multiplied by v is simply equal to u times dv dx plus v times du dx, where we just get those values or those terms from this right hand side. So therefore the derivative d dx of x cubed times e to the power of 2x is going to equal, and our term u was x cubed, so we have x cubed multiplied by dv dx, which is 2e to the power of 2x, plus the term v, which was e to the power of 2x, multiplied by du dx, which was 3x squared. And we can just do a little bit of simplification here, essentially just taking out those brackets. So this first term I'm going to write as 2x cubed e to the power of 2x, plus, and the second term I'm going to write as 3x squared times e to the power of 2x. So that is the answer for part A of this question. So as we can see, close to 80% of students got this fully correct, and 9% of students almost got it right. And we can see that this was a differentiation question involving the use of the product rule, which we did on the previous slide. And the examiner's comment is that some students who applied the rule correctly then factorized incorrectly. So students are strongly warned against over-engagement in the questions. So for example, factorizing when that's not required. So leaving your answer as it's stated here or on the previous slide was sufficient. For part B of question 1, we have f of x equals log e of x squared plus 1, and we're asked to find the derivative evaluated at 2. So the first thing we can see is that this is a function inside a function, so we're going to use the chain rule for differentiation. And to apply the chain rule, I'm going to let y equal log e of u, where u is the inner function. So that means that u is equal to x squared plus 1. So we can now differentiate, so we can do dy du, which is going to be 1 on u, and we can use the formula sheet to find that rule. And then next we have du dx, which is simply equal to 2x. So from the formula sheet, our chain rule says that dy dx is simply equal to dy du times du dx. Therefore for this question we have f dashed of x is equal to dy du, which is 1 on u, but I'm going to replace u with what we know u is, which is x squared plus 1, and then we multiply that by du dx, which is 2x. And we can do a little bit of simplification here to write this as just 2x divided by x squared plus 1. But that wasn't what the question was actually asking for. We were asked to find f dashed of x at x equals 2. So therefore we want to evaluate f dashed of 2, which is going to equal 2 times 2 on the top line, divided by 2 squared plus 1. And then simplifying that down, 2 times 2 is 4, and we have 2 squared is 4 plus 1 gives 5 on the bottom line. So f dashed of 2 equals 4 divided by 5. So from the examiner's report we can see that 60% of students got that fully correct, while there was 35% of students who got 0 marks for that question. And the comment is that many students had difficulty applying the chain rule. And the common mistake here was that students often did not multiply by the derivative of x squared plus 1, which is this term here. So that was the derivative of x squared plus 1, which needed to be differentiated and then multiplied by dy du to complete the chain rule. So it's really important that you don't forget to multiply it by the derivative of the inner function.